It's time to start asking why, and we'll get some answers.
Sounds good.
Our wise guy, Matt Selen, joins us live this afternoon, this morning, whenever we are. He is an experiment that's going to make us hot for physics, Matt.
I hope so. It certainly makes me hot for physics.
Well, what have you got?
So, well, actually, I want to talk about hot and cold and heat transfer today and also next week. But before we do that, Robert asked a really great question at the end of the last segment. And he asked about these things that you see in science fiction movies where you have the two vertical conductors and you have a spark that moves up between them and it makes a cool sound like zzz and so on. And so I have one of those machines here. We built it with some students a few years ago. It's in the lobby of Loomis and anybody can just walk in and push this button if you want to try it. So it's right here to my right. And so what you see here, there are two aluminum conductors that go up, and they start close together, and they sort of spread out as they move upward. There's a very high voltage power supply down here. When I push this button, I energize this thing, and we get a high voltage between these wires. And what happens is an arc forms at the bottom, because this arc, and you might be able to see it here, because the arc is hot, and hot air rises, the arc moves up. This sort of ladder it's called. This is called a Jacob's ladder. And so, I don't know if you can hear it if I stand really close.
Yeah, we can hear that.
But it makes a sort of really nasty zzz sound that really makes you think of Frankenstein movies. So I love this thing.
And that's the electron transfer that you were kind of talking about last week?
Yeah, this is what you have here is a spark, just like we were talking about before, but because we have a big high voltage power supply, the spark just keeps on going. It becomes a plasma arc, basically, and it makes that cool sound as it moves up.
And what makes it stop going up? What happens there at the very top that makes it go away?
At the very top, the wires are just too far apart, and it just can't jump that far anymore, and it stops. And then it picks up where it left off at the bottom, where they're very close. And it's very easy for it to get started at the bottom. Okay, so back to heat and cold and so on, and we'll get to more of this in the next segment. But here, what I have is different materials that are dunked in a bucket of liquid nitrogen. And I don't know if you can see this, but I have a thermometer that's in the liquid, and it says that it's minus 313 degrees Fahrenheit. So it's very cold stuff. And so what we're going to talk about next in the next segment here is why some materials conduct heat very well and other materials don't. And the quick answer is that if it conducts electricity really well, that it probably conducts heat really well as well. So we have things here like copper, which conduct electricity magnificently well. And what you see here is that it must be very cold because the frost has gone all the way up on this copper rod. That's what this is. A piece of wood, of course, isn't frosty at all. It doesn't conduct electricity or heat very well. And so we'll get to more of that in the next segment.
We notice you're not touching that copper pole.
That's right, because it's really cold and I don't want to get frostbite.
Yeah. All right, thanks, Matt. We'll join you later again this morning.
Okay.
Well, still to come this